Okay, question 6 is where we are next. And it says how many grams of potassium chlorate, so that's KClO3, which is this little rascal right here. How many grams of KClO3 must be added to 1 liter of water to produce a saturated solution at 50 degrees? So I'm going to find 50. I'm going to go there, and I'm going to come over to here. Looks like to me it's about 22 grams, but that's per 100 milliliters. I'm talking about a liter, so that's 10 times more water, so that's 220 grams. Okay, number 7 says a saturated solution of potassium nitrate is prepared at 60 degrees Celsius, so let's find our potassium nitrate, KNO3, right here, at 60 degrees Celsius, so I'm about right there, and using 100 milliliters of water. So that means that I must have had, I don't know, maybe 104, 105 grams, 103, something like that. So I'm going to have 103 grams. But then I'm going to cool it down from 60 to 30, which is what you did in the lab. Oops, KNO3 is what I was supposed to be looking at, so we should have stopped about way down there. Sorry, that looks like to me it's about 48. So 103 minus 48 tells me that 55 grams of my KNO3 are going to fall out of solution. That's what it means by precipitate. So they're going to fall down to the bottom of the test tube. Okay, number 8 says, what is the average rate of increase for the solubility of KNO3 in grams per 100 milliliters per degree Celsius in the temperature range of 60 to 70? Okay, so I'm looking at KNO3. So I'm going to erase all this stuff and look at KNO3. And I'm going to go from 60, 40, 50, there's 60, to about 70. So that looks like about 30 grams per 100 milliliters of water over 10 degrees. So I took 30 over 10, or got 3 grams per 100 milliliters per degree Celsius. Okay? Okay, so that was number 8. Now let's go on to number 9. Number 9 says, if 50 milliliters of water that is saturated with KClO3 at 25 degrees Celsius is slowly evaporated to dryness, so we're going to take all the water away, how many grams of the dry salt would be recovered? So we have to go find out what we started out with. And we're looking at KClO3. So we were at 25. So I'd say that's about 10 grams. I want to evaporate it all away. So that looks like to me it's about 6 grams. So 10 grams minus 6 grams tells me I would have 4 grams of salt. Okay, number 10 says 30 grams of KCl are dissolved in 100 milliliters of water at 45 degrees Celsius. So let's find out where that is on our little chart here. Didn't mean to scribble like that. Sorry about that. So we were looking at KCl. KCl is this little one right here. And it says 30 grams of KCl are dissolved in water, 100 milliliters of water at 45 degrees Celsius. So here's about 45. So we could have had a little bit different than that, because at 45 we know that it could hold up to 40 grams. And we had 30 grams. So how much additional KCl is needed to make the solution saturated at 80? All right, so we were at 40. Oh, I'm sorry, not at 45. Way to go, make a mistake and have these kids trust you. All right, so we were at 25. Sorry. And then we want to go to 80. So at 80 it looks like there's about 50 grams to make it saturated. And at 25 we had about 25 grams, or I said 30 grams. I'm going to say 35 grams. So if we wanted to make it saturated, we needed 15 more grams. Okay, number 11 we omitted because we didn't care for the question so much. Okay, number 12 said, what is the lowest temperature at which 30 grams of KCl can be dissolved in 100 milliliters of water? So I'm going to find my KCl, which is still that same thing. 30 grams would have been about right there, so I'm going to read over and go down. It looks like it's 10 degrees Celsius. All right, number 13 says, are the following solutions saturated, unsaturated, or supersaturated? Okay, my kids had some trouble with this until they understood some things about reading a graph. Now, all these dots on the line, all these points that were plotted to make that line, those are all saturated solutions. So if it appears on the line, then it's saturated. If it's above the line, it's supersaturated. If it's below it, it's unsaturated. So let's take a look at what they're talking about. Okay, KCl, which is this one here, at 80 degrees Celsius. So I'm going to go KCl to 80. And then they're talking about 40 grams. Well, 40 grams would be way down here, so it's not on the line, so that one is unsaturated. Okay, part B says, that was A. Part B says 120 grams of KNO3, so let's find our KNO3. It's up here. 120 grams, and my temperature is 60. So I'm going to go to 60, which is this one here. And I'm going to go here, and I got to go to 120. So 120 is way up here. It's above the line, so I'm going to call that supersaturated. 13C I'm going to put over here. And 13C is asking me about 80 grams of NaNO3. NaNO3 is right here. 80 grams at 10 degrees Celsius. So right there, it meets with the 80 grams. So that tells me, since it lies on the line, that that one is saturated. Okay, 14 says, assume that a solubility curve for a gas such as ammonia at 1 atmosphere of pressure was plotted on the solubility curve graph. So here's my ammonia right here. That should actually say NH3, and it goes downward. So reading from left to right with this curve, it would go sloping downward. Answer B. Because gases are always, well, not always, but typically gases decrease in solubility the hotter they get. And we thought about soda, Dr. Pepper, and you know, if it's warm and you try to open it up, you're going to get sprayed with soda because that gas is going to come out of solution. 15 says, which of the salts has its solubility affected the least by a change in temperature, and that would be NaCl. If you look at NaCl, it doesn't rise much at all. It's pretty much a flat line. All right. I would read through my notes because there will be questions that come from the notes. Even though I didn't go over the notes, you have them. Read through them. And know that you can come in and get help from any of the chemistry teachers if you need any.